All right, topic 8.1 is the average value of a function. We're beginning a new unit today, and here's the idea. The average height of the function will equal the area under the curve divided by the width of the integral. And this is our important rule right here. Basically, we're finding the definite integral, but then we're multiplying it by this little piece right here, by 1 divided by b minus a. It's just the definite integral, but then we're multiplying it by that 1 over b minus a. And b minus a, of course, is the distance from there to there. All right? Please make a note to yourself. Do not confuse average value with average rate of change. They are not the same thing. And students do that all the time. Don't confuse those two. So doing this, actually using the average rate of change is really a pretty easy proposition. We just need to use the formula. So let's look at a couple examples here. First example, find the average. Again, notice it says value, not average rate of change. It's saying average value of the function over this interval. So I'm going to have 1 over 3 minus 0 times the integral from 0 to 3 of my function, which is x squared plus 2 dx. Pretty easy example. All right. My antiderivative is, I'm going to come over here so I have some more room, x cubed over 3 plus 2x. I'm going to evaluate that from 0 to 3, and I'm going to multiply it by 1/3. So really, like I said, the only thing that changes is when I'm asked to find average value, what changes is this little multiplier out in front. Other than that, it's just a definite integral. All right. So we plug in my 3 here, and I have 27 over 3, which is 9, plus 6. And I'm going to subtract, plugging in 0, which is just going to be 0. So I'm going to have 15, but I need to multiply that by my multiplier of 1/3. And so I get 5. All right, so it's really just finding the definite integral and then multiplying it by the multiplier. All right, let's look at example 2. Find the average value of the function over the interval negative pi halves to positive pi halves. So I'm going to have 1 over pi halves minus negative pi halves as my multiplier. So when I subtract a negative, it becomes addition. So my multiplier is going to be 1 over pi, because I'm basically adding those pi halves together. And I'm doing the integral from negative pi halves to positive pi halves of my function, which is 2 cosine of x. And so my antiderivative of that is going to be 2 sine of x evaluated from pi halves to negative pi halves and multiplied by this 1 over pi. So I've tried to preach to you that the easiest way to remember some of these values of trig functions is by remembering our base graph. Okay, so here's pi halves, and over here is negative pi halves. So this value up here, the y value is 1, and down here the y value is negative 1. Just a quick little review of some trig stuff there. So when I do 2 times the sine of pi halves, I'm going to subtract 2 times the sine of negative pi halves. Of course, that's going to be multiplied by 1 over pi. The sine of pi halves is 1, so this is going to be 2. This thing right here is negative 1, so this is going to be like adding 2. That is multiplied by 1 over pi, so my answer is 4 over pi. Okay, let's take a look at one more here before we, this one's more of a multiple choice type problem, but it's the same type of problem, it's just packaged in a multiple choice problem, which of course we know we have to deal with on the test. Average value, so I'm going to have 1 over 2 minus 0, so that's going to be 1/2 times the integral from 0 to 2 of x squared times the square root of x cubed plus 1 dx. Okay, calculus students, what are we going to have to do something with this antiderivative here? What are we going to have to do? Yes. U substitution, right? So we need to let u equal x cubed plus 1. So my du equals 2x squared dx. And I need to introduce another 1/2. Okay. Wait a minute. This is not 2x squared. This is 3x squared. So we need to introduce a 1/3. So this turns into a 1/6 out in front. That's one of the reasons I wanted to go over this problem. Remember, 1/2 times 1/3 is 1/6. I'm integrating from 0 to 2 of u to the 1/2 du. So that's going to become 1/6 times u to the 3/2 over 3/2. So that's going to be like 1/6 times 2/3 u to the 3/2 factor, and my multiplier is now going to be 1/9. I need to put my u back in, which was x cubed plus 1. Okay, it is to the 3/2 power, and I'm evaluating it from 0 to 2. So when I plug in my 2 here, 2 cubed is 8, 8 plus 1 is 9, so I have 9 to the 3/2. So the square root of 9 cubed, the square root of 9 is 3 cubed, so that's going to be 27. All right. I need to subtract what I get when I plug in 0. All right. So that's just going to be 0 cubed plus 1, which is 1. So this is going to be 27 minus 1. Don't forget, we're multiplying it by 1/9. So we're going to have 26/9. Okay, and we will stop there for today. get you started on topic 8.1.